Okay, so here we go. We're gonna talk through page 6. I think I'll start doing notes by pages, and then that way they don't turn into long videos, and we can go about it that way. So here we go. We're gonna work on displaying numerical data. So that's the key word. We're talking about numerical. We do that in 4 different forms, as far as dot plots, stem plots, histograms, and box plots. Like I said, we can go out and do an applet. We'll create most of these. However, we'll get onto our calculator. Histograms and box plots, our calculator will do for us. And so we'll talk our way through that when that time comes. Okay. So when we're drawing numerical data, we need to make sure we label our axis. And could someone read your graph and understand the problem without reading the problem? So our first one is going to be a dot plot, is what we're going to create right now. We have total goals scored by individual teams in 2019 Women's World Cup is the data that we have listed here. We need to turn that into a dot plot. So I'm going to go to the bottom just because we're going to come back to this problem on the next page, after the next page, and see what we have there. So we're going to draw our line. We're going to draw our axis, and I guess you should be able to see the axis if I draw it. Okay, and this is going to be goals scored by teams at 2019 World Cup. Guess you need to be able to see that too. All right, so we're going to scale this. So it looks like we start at 1 and we go all the way up to 24. So it looks like that's something that we can just scale. There's 0, 1, 2, 4, 6, 8, 10, 12, 14, 16. I should pause the video, and then that way you don't have to hear me numbering. But yeah, too late now. We're there at the end. Okay. So in a dot plot, and actually here we got to go to 25 goals. So because the USA scored 25. So that's what we're going to do here is we're just going to plot those dots. So we have a data point for the United States. This isn't very big, so we'll have to keep sliding the paper. We have a data point for the United States. It's 25. So we're going to come down here above 25, and we're going to put a dot. England scored 13. It gets a dot. Sweden scored 12. Netherlands scored 11. Germany and France scored 10, so we're going to put a dot above, 2 dots above 10. We got Italy at 9. We've got Australia at 8. Brazil at 7. Nobody scored 6. We've got Norway and Scotland at 5. We've got Canada and Spain at 4. We've got Argentina at 2. I don't know why that's out of order. We're going to go back to Japan and Cameroon at 3. And we've got 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, and 7 dots above 1. And we have one team that got to play scored 0 points. Okay, so we have created a dot plot to turn our numerical graph into something we can picture, something we can describe. So now that we have it in picture form, now we're going to describe it. Okay. Now let's talk about the pros and the cons real fast. This is nice because we get to see each individual piece of data. When we move on to histogram, you'll see what we mean by others displays that we can't. The con is not useful for large sets of data. Here I had 24 dots to plot, which wasn't too bad. But if I had 2,400 dots to plot, that would be a pain. Okay, so I'm going to move on to page 7. Just because to finish out this problem, we need to come back to it. So here we go. We're going to talk about examining. So what we have to do is we have to be able to describe a set of data. excuse me, it's not a set of data. We're asked to describe a distribution. So let's talk about how we're going to describe a distribution. Okay. I have socks up here, socks BS up here. I'm actually going to do something different this year. We're going to call it our C socks. Okay. Our C socks. And again, what that stands for is the C is going to stand for context. Okay. And the other S's are out here to the side. So our first S. Okay. If you had to remember, and it's hard for me. I'm used to saying socks all the time, so I'm going to change to C socks, and we'll see what happens. But our first one the first S in there is going to stand for a shape. So what we're going to try to do is we're going to try to describe the shape of a distribution. Okay. When you describe a distribution shape, concentrate on the main features. We're going to look for rough symmetry or clear skewness. Okay, so we have to talk about what do all those words mean. Okay, so when we have a set of data that if I drew a line down the middle, it's roughly the same on both sides. If we drew a little curve to that, it looks very much like a bell curve. Okay, that is going to be the same on the left and the right. We're going to call that symmetric. All right, now this one, the following one, if I drew a bell curve here, that bell curve would look like that. Okay, I drew it wrong. There's a lot of extra information out here. So this is considered what we call a right tail. Okay, so in that right tail, that is going to tell me the direction of my skewness. Okay, so therefore this is going to be skewed right. If again I drew my normal curve, all right, there's what the curve looks like. It stopped there, it stopped there. I have extra information here. This is going to be a left tail. So that means this particular distribution would be skewed left. Okay. All right, that's all the words that we use to talk about shape. Actually, there's a couple other words that we use in describing shape. One of those words is unimodal. Unimodal means one distinct peak. The other one, and so this is going to be a unimodal. All three of these are going to be unimodal. They have one distinct peak. Okay. Bimodal would be another word that we use. Okay. It has two distinct peaks. As far as something that might be bimodal, typically the length of hair is bimodal. Guys tend to wear shorter hair, girls longer hair, and so if we looked at a distribution of hair lengths, we would see something that is bimodal. Okay. Um, so with that said, let's come over here and do I want to finish? Do we go all the way through this? We'll go all the way through that. Okay. O stands for outliers. Okay, they are going to be, and actually I did this out of order. I should put that there. Individual values that fall outside of the overall pattern. Okay, so this still falls within the pattern. There would be no outliers. If I had some piece of, like if I was looking at this one here, and I had another dot that was clear down here, this dot would be considered an outlier. Okay, it deviates from the overall pattern immensely. Okay, these three right here actually may be outliers itself. When we get to that portion, when we do a box plot, we'll figure out a way to mathematically calculate an outlier, but not right now. Okay, C is for center. Which is going to be the approximate middle. And your other S stands for spread. Okay, that can either be min to max, or it can be the actual range. Okay. So here's what we need to be able to do. Now we're going to go back to the dot plot, because what was the purpose of a dot plot? We'll just take a picture of the data, the distribution, and now we want to be able to describe this. So we're going to come back to our dot plot that we made for goals scored, and we need to be able to describe this. Okay? So first of all, so remember, we're going to do our CSOCs. Okay? That's just an acronym to help us remember to what to do. So, first of all, C stands for context. What is my context here? The distribution of goals scored at the 2019 Women's World Cup is, and this is where you could either continue on with a sentence or do whatever, but now we're ready for S, spread. Okay, so I didn't do a very good job of spacing this out. So, not spread, shape. Okay, what is the shape of this distribution? Okay, so if we come down here, we have a distinct peak here, we have a cluster, and then this spreads out way to the right. So therefore, the distribution is skewed right with an outlier at 25 goals. So we've taken care of the outlier. The approximate middle of the distribution is about, and now we need to know what a middle is. Now, because this is skewed right, and we haven't got into this discussion at all, we cannot use we have mean and my median are my two measures of center. And one of these we can't use right now because this is skewed to the right. It's going to have a great impact on my mean, and it makes the mean null as far as a measure of center. So I need to use the median. I've got 24 countries here. Half of 24 is 12. So between the 12th and the 13th country is going to be my median. So here's 12 and here's 13. So that means it's going to be the difference between the halfway point between 4 and 4. All right, so is about 4 goals. So the typical country scored about 4 goals. USA scored 25. New Zealand, 0. Anyway, and now so we've taken care of that part of it. So we check that off. And we would just check, you could write that to the side and you can do check marks as we go through it. It's totally up to you on how you want to use this. But our last one's going to be spread. The range of scores is from 0 to 25 for 25 goals. All right, so again, CSOCs. We have to have some type of context. We had to talk about what my variable is, what my unit is. Okay, my variable was number, in this case, it's the same. My variable was goals. The unit for goals is goals. We talked about its shape, it's skewed right. We could have included unimodal. We have the outlier, we have a center, and we have a spread. So again, that's the things that we have to talk about when we are asked to describe a distribution. Okay, I'm going to stop this video and we'll pick up with another one.